morning, good afternoon, good evening, everybody. Thank you for joining this KX live stream. My name is Ryan Siegler. I'm a developer advocate here at KX and happy to be joined by Conor McCarthy, the VP of Data Science. Conor, if you want to say hello.
Hi, everybody.
Awesome, thank you. And today we've got really a very exciting presentation about the new PyKX 3.0 that's going to be released. There's some awesome features that are going to be coming out within this release. So we're just really excited to talk about that today. Now, before we get started, give people some time to join. I'll just go over a few brief housekeeping items. First of all, yes, this is being recorded. So after the session completes, you will be able to access this on both LinkedIn and on YouTube, basically immediately after the session is done. So you can go back and replay your favorite part. Also, we have a comment section where we encourage you to ask your questions, and we will do our best to get to them at the end of the presentation and answer all the questions that you have. And if we aren't able to get to all of them, we can also answer them in the comment section after the presentation. And just to get started, if you wouldn't mind putting a number between 1 and 5 in that comment section, talking about what is your experience with PyKX. So number 1 being you have no experience at all, and number 5 being you're an expert in PyKX and you work with it all the time. That'd be really helpful to us. And we also want to just say that this presentation is meant for all experience levels. So whether you're a beginner with PyKX or someone who's worked with PyKX for a long time, we think this presentation will be really useful to you. So if you don't mind just putting number 1 to 5 up in the comments, that would be awesome. Now, a couple more things on resources to help you learn PyKX and learn about PyKX. So number 1, we have a KX Academy. And that's a place where you can go and learn about all the different KX products that we have. And there we also have a course on PyKX called Introduction to PyKX, where you can learn all the basics of PyKX from data structures and data types all the way to even some pretty interesting time series analytics. And it just takes a couple hours to go through that course. And then once you complete it, you get a certification. So we encourage you to check that out. I'll go ahead and put the link in the comments just in a moment here. But one of the awesome things about the KX Academy and the courses you can take there is you have access to a fully pre-built sandbox. So you can try out using PyKX and go through the course and the examples that we have there, as well as try your own examples in that sandbox without really having to do any sort of setup or installations. We have it all set up for you there in that sandbox in the KX Academy. And then the last thing I'll mention is we do also have a KX Slack channel, and you can join that at kx.com/Slack. You can get direct access to myself and Conor asking all the questions that you have or just discussing the general topics about PyKX and data science and things like that. We're happy to have a conversation with you there and answer all of your questions. All right, well, I think that covers my housekeeping items. So Conor, feel free to take it away. Thank you.
Sure. Thanks a million, Ryan, for the introduction and for introducing PyKX so succinctly. Okay, so what I'm going to discuss today and walk through really is kind of to a degree what PyKX is for new users and new people that are joining today, but quickly pivoting into what we're doing for our next release and obviously discuss when that release is coming out. So how long you're going to have to wait to play around with the features. So to get started, for users unfamiliar with PyKX, or at least that require a bit of a refresher, PyKX is a Python-first library for integrating with the world's fastest time series database, KDB+. So really, its functionality and what it's intended to do fits into 3 categories today. And obviously, with the new release, there's kind of enhancements to those, and we'll discuss those over the course of the next 40-ish minutes. So the first piece is running time series analytics fast. We have users that are replacing existing analytic workflows with faster and more efficient Python code using PyKX. There's a pandas-like syntax for interacting with in-memory data objects. There's a interface to SQL that exists within it, and users have full access to KDB and Q if they're familiar with the programming language and if they want to run more advanced operations. A proof point in this is a presentation that Citadel, the investment banking, produced at KXCon last year, where they were creating complex event processing workflows using PyKX, taking analytic runtimes from minutes to milliseconds for workloads that had previously been on NumPy and Pandas. In the center, we talk about creating massive databases easily. PyKX provides functionality for maintaining and interacting with databases at terabyte plus scales using simple syntax. So users can generate databases from data formats that are common to them, run efficient analytics on those databases using Python without being an expert in Q. And some of what I'll discuss today is kind of the next phase of that versus what's there today. And in addition to that, users can maintain their databases, allowing them to rename, modify, delete, add columns to on-disk databases. The final piece is for integrating with your own infrastructures. Mainly and usually we discuss that in the context of integrating with Q infrastructures that exist today in major banks or in our clients more generally. But it falls into a number of different areas. So users can query existing infrastructures faster and more flexibly than had previously been allowed with other Python interfaces to KDB+. Users can now integrate, as of a couple of months ago, Python code into the KX dashboards tooling. And in addition to all of that, users can bring the power of Q anywhere where they have data science needs and want to run it Pythonically. So Snowflake, Databricks, on-prem, at the edge, anywhere where Python will run and Q would run, PyKX is able to run. Okay, so that's the state of the world today. But why are we all on this stream and watching back? Really, it's around what's new in PyKX 3.0. There are a lot of features that will exist for the release and a lot of features that I'm not going to really mention today. But the three headline features are a new Python first query API for in-memory and on-disk data. The API itself is a significant milestone for the library. It provides the ability for users to who are familiar with Python principally to focus on running analytic tasks on data at large scales with a massive focus on extensibility and familiarity. For users that are familiar with query APIs like Polars, the syntax that's provided should be really, really familiar, but allowing users to operate on memory map data at scale. In the second case, we're providing a high performance Python first streaming workflow. So users will be able to generate basic data ingestion pipelines in 2 commands, extending those with gateways and real-time processors. And in addition to that, allowing them to register and run APIs written entirely in Python for ease of use purposes and using step 1 prior to that, or the first element, making it possible for them to generate really, really complex workflows. And then part 3 is data conversion performance upgrades. So we've had a lot of feedback from users on particularly the conversions from Pythonic data types to PyKX. So getting data from formats like Parquet or anywhere that they have Pandas data. We've had a significant overhaul in how we do our data conversions. So on average, we're now 4 times faster than the current version of PyKX for converting data formats from Pandas to PyKX. This is kind of achieved through a couple of things, but mainly it's been a migration of our code from Python down to C++, the enablement of the NEP49 protocol for zero copy conversions from NumPy to PyKX, and the addition of multi-threaded data conversions from Pandas to PyKX on the tabular side of things. Okay, but it's a major release. We've been silent largely for about 6 months. So what else are people getting? There have been a number of features that have been in beta for the last approximately 8 months. Those have been database creation and maintenance, APIs for easy Pythonic compression and encryption, integration with Streamlit functionality for the remote execution of Python code on Q servers, and PyKX threading for running PyKX in multi-threaded Pythonic ecosystems. All of those features are now being promoted to production. That beta feature process involved lots of discussions with clients and ultimately working to hone out and figure out the issues that we had with the APIs as they stood. Everything is now stable, and we're happy to move them to production support. I'll show this a little bit later on, but we've had a number of enhancements to our Jupyter integration. So there's now a queue first mode of PyKX, which will allow the Python kernel to be used in a queue first mode. Showing that is easier than explaining it, so I'll show that a little bit later on. I've had some improvements on performance for the HTML representations of the data that we're showing on disk, but those are relatively minor. Additionally, what I'll show a little bit later is help functions for Q keywords. So right now, if users use the Q keywords like kx.q.max or kx.q.moving_average, they try and use Pythonic help, the result is it's a generic lambda. We've now provided doc strings for all of those. In addition, Q operators are now all callable. So there are named versions of drop and take and fill and enumerate and so on that allow users to build up more complex Q analytics, but from a Python first perspective. Again, they all come with help, and I'll show those as we go through the demonstration in a little bit. There are, of course, more additions to the Pandas API that we have. We've added a map function, an apply map function, reorder columns, and we're adding a pivot. In addition to that, we've provided callable generators for Python dates and times, or Pythonic dates and times, to create KDB objects. I'll show those as we go through, and provided APIs for managing enumerations easier. And it wouldn't be a major release without a significant focus on fixing issues that kind of have come up over the last while, but have been more difficult to release updates for in minor releases. So there are some fixes to PyKX under Q. There are the addition of functions to allow string objects to be represented as char vectors to Q, and other pieces of functionality that users have been looking for that kind of should improve the user experience more generally at the edges of performance, but also at the edges of the API. Okay, so the scary part for me now, running the live demonstration. What I'm going to do is, over the course of the next probably 20 minutes, 30 minutes-ish, do a number of things. So there's kind of 3 or 4 distinct sections to this. Firstly, I'm going to show the new query API, how that looks and how that feels for a Python user. We'll show some simple queries, building up to some more advanced, and then talking about some of the customization that's possible for users to allow you to extend the API. Following that, I'll generate a full streaming workflow. So I'll use the historical data that I'm querying now, build up a ticker plant infrastructure for streaming data, which is a KDB construct for ingesting tick history in finance. I'm going to generate a derived streaming analytic from it, create a user permissioned query gateway, which allows me to query across both historical and real-time data. Finally, I'll show some of the updates to the API for interactions with Q. Okay, so all that said, firstly, I am going to import PyKX as KX, and we'll get started. A couple of helper libraries that I'll use throughout, but the first thing that is to be done is to load my database. So for the purposes of this, I have loaded a database called database in this instance, which contains minutely financial data. Specifically, it contains currency commodity pairs and currency pairs. So wheat USD, euro USD, and gold USD prices per minute over the course of about 15 months. So what we have here basically is a huge amount of data that, well, huge amount of data. It's about 10 million rows of data, which I'm going to start querying. So if we look at the query here at the bottom of the notebook, you can see what the equivalent Q query would be for, instead of having the minutely data, calculating the daily open, high, low, close for the commodity pairs. So we would select first open, last close, max high, min low, sum volume from the minutely data by date and by symbol. That syntax is terse, it is expressive, and it allows us to be in a position where we can produce much more significantly complex analytics. And as we'll go through this, you'll start to see how I am expanding what we're doing. But in the most basic case, the new Pythonic syntax looks as follows. So users have the ability here to take db.minutely and run a .select command against it. This is a new part of the API as well. We have the ability for users to run selects, updates, deletes, and execs directly against the objects that they're querying, the table objects. So the most important part of the additions to the API are the addition of this column object. The column object basically allows us to create complex query trees that we can run against our databases and our in-memory tables. So in this instance here, for our columns, for the analytics we want to run for the open column, get me the first value, for the close, get me the last, for the high, get me the max, for the low, get me the min, and for the volume, get me the sum. I want to do that by date info and sim. I then want to sort the result on date info, and I want to remove the key to make it an unkeyed table. So if I run that, that's running directly against the partition table, so against the 10 million records, and I can get the result back that shows me the now new open, high, low, close for the currency commodity pairs in this instance. Okay, so that's trivial. That's a very, very basic vanilla Q query. If we start to get more complex, we can get into situations where we need to chain commands together. So in this instance, I want to calculate the volatility of the daily prices by symbol from the open, high, low, close. So in this case, I want to run my select statement. So select volatility, or volatility equals the ratios between individual values in my close. I want to drop the first element, which is a null value. I want to calculate the log of the result of that and then get the deviation, which, bringing that all together, calculates for me the volatility. I then want to make the table ascending on volatility. So the way that that's done with the new API is basically by allowing users to chain together operations and commands. So the order in which they present themselves for the user is reversed. But from a right to left reading perspective, you can now calculate for kx.column close, get me the ratios between values, drop the first element, get me the log of the result, and get me the deviation of that, renaming the column as volatility. Do this by symbol and then sort the values on volatility. So if I run that, I now get a key table, and that key table provides me the volatility for the daily prices. So I mentioned, as I was kind of talking at the start, that selects are not the only operation that we've provided. Users can run deletes and they can run updates and execs against it. So an example of delete in this instance would be for the daily open, high, low, close, delete anywhere where the symbol is Euro USD and where the volume is greater than the average volume. So in this case, run daily open, high, low, close, delete, where kx.column sim is equal to euros USD and where the volume is greater than volume.average. So an important part of this is that in addition to obviously the functionality that allows you to chain against columns, we're providing the ability for users to use directly the Pythonic dunder methods that allow them to do comparisons. So for example, here equals will become an equals and Q, and greater than is obviously greater than. So the degree of composability on this kind of extends fairly significantly. So if I run this delete, the volume now, yeah, so we've now removed basically any of the volume where volume is less than the average. Okay, so that's kind of like a very, very brief introduction to the very basics of the API. And I'll show more complex examples as we go. But one thing that's probably worth noting before I show a very complex example of a query is the range and amount of functionality that we're adding with this. So the kx.column objects themselves basically are a constructor. They allow us to produce the queries. But on them, there are approximately 100 different functions that users can take to build up complex queries. So for example, you have access to functions for filling null values. You can index sort your data. You can join data together. You can trim strings and so on. And in each case, the functions come with associated help information. So if I take, for example, correlation, and I get help on that, you'll be provided with the complex options that are available to you. So for running iterators, i.e. running the correlation on each column or each row in the column that you're running against. But additionally, you'll be provided, and it's truncated here, but with full examples on how to actually run this in practice. So moving from kind of the basic introductions and the introduction of the interactions with the dunder methods and Python's kind of inbuilt pluses and minuses and so on, I'm going to run a more complex example. So this is probably a more practical use of it in kind of a larger scale case, using more of Q's kind of beneficial features. So I'm generating two random tables here, trade and a quote table. And what I'm going to be calculating is some information about the trade statistics, so the trade and quote, the statistics about the data that exist for it, and additionally calculating a time-weighted average price for the data. So this is synthetic data; it's not real in practice, but you can get to a position where I'm going to just zoom out very slightly, where you can build very, very complex workflows for calculating structures in financial data and just more generally in kind of any data set that you want. So in this case here, the example that's probably the most prescient is to talk about actually calculating the time-weighted average spread. So in this instance, for the quote data, we can do things like get me the next time within the time column and subtract the previous value. So get me the difference in time between two successive moments, and then calculate the weighted average between that and the ask and the bid price, renaming that the spread of the time weighted average. We additionally calculate stuff like the average duration of a trade, which is essentially what was used above, but would be provided for a user from a statistical standpoint. But we're doing more than that. So we're running an exec against the table in the case that trades are equal to none. So we can get an idea of the symbols that exist within our data for running our query in a more generic case. Doing very similar for the trades. So we calculate similar metrics on the trades data and then run a union join between the two. There's a couple of things that are probably important to note for people that are familiar with Q. In that we have tried as best we can to be as true to the Q syntax for pretty much everything as possible. But there are elements that are difficult in Python for us to do on that. And there are areas where, from a Pythonic standpoint, it makes more sense to change some of how the APIs work. As I said, they're all documented, but a good example is the use of is-in instead of in. So in Python is a keyword. So overriding it causes a bunch of problems. So we want to find anywhere, in this case, where kx.column is in a list of symbols. So we now have is in instead of in. And additionally, the use of within in Q takes a list of objects. It takes a start time and an end time as one single list. For the purposes of readability and usability in the Python API, we split that into 2 parameters, a start time and an end time. So if I run this and I now run my command to generate the TWAFs, we can see that runs. So passing in Apple, I get back the information about the trades for the Apple stock. Passing in nothing, I get the distinct symbols that exist, and I get the result back in the end. Okay, so that's kind of the highest level view on what the new query API looks like. Myself and the team are very aware, however, that we don't know everything about everybody's domain expertise. It wouldn't be sensible for us to try and build in lots and lots of very specific aggregation functions and functions that run across multiple columns. So as a result, what we've been trying to do is to make the API as flexible as we can. So in the following kind of 3 cells, I'm going to add a new method that can be called against a column object. So in this case, what I'm going to generate is a min-max scaling function. Basically gets the minimum value within a column, the maximum value within the column, and then divides everything by the values to get a 0 to 1, basically, in the table. So if I run kx.register.column_function, say that I want the function to be called min-max and pass it in the min-max scalar function, I can then use that function directly against the price column. So in this case here, I'm running an update, but I want to update kx.column_price, run the min-max on it, and rename that as the scaled price. Do that by symbol. So when I run this, we now have an addition to the trade column, which is the scaled price. So this level of flexibility provides a number of things, but very specifically, it makes access to PyKX and the ability for you to build libraries on top of it significantly more valuable, because you can provide domain information to your users, which allow them to get the maximum out of the domain expertise that exists within your teams to the users that are ultimately consuming the functionality. Okay, so that's the query side of things. On the streaming workflows, Python itself is particularly poor at building streaming workflows. It's not built for streaming, it's built for data science principally. When streaming starts to come into things on the Python side of things, you're largely talking about building subprocesses or building functionality that runs a Java process in the case of Kafka, or here runs queue processes. So what I'm going to do is I'm going to consume currency commodity pair data at a frequency of 1000 Hertz. I'm going to generate minutely open, high, low, close information from that consumed data and provide a query gateway to query across the real-time and historical data. In the next 10 minutes, I'm basically going to build this infrastructure. So for users that aren't familiar with Q, ticker plant is the kind of most basic way that anybody builds their streaming infrastructures. On day 0, usually kind of month 1 in your learning process, you end up learning about ticker plants, and ticker plants allow you basically to take in a feed of data, log the incoming records that you have so that you can replay the data, and then connect that to a streaming infrastructure that allows you to consume new data. Ryan, I'm sure, will be able to put a link into the tab on the Academy course that our colleague Michaela has done on this for real-time architectures within Q. But this is essentially an abstraction on that for PyKX. So what we're going to do is start the ticker plant, real-time database, and historical database with 2 commands. So this takes about 16 seconds to start because of the internet. But what I am doing here is generating a schema for the data I am going to be consuming, which contains temporal information, contains symbol information, and contains price. Starting that basic tick infrastructure then says, what are the tables that I'm going to be consuming data from? I'm going to be consuming a feed of data with a schema called pair schema. I can have multiple of these tables. I'm going to be saving my logs to a directory called log, and I am going to have a database, which is current working directory. So that database I've already loaded. If it hadn't been loaded into the process already, I would be passing an absolute path to this. So when I start, I basically start my ticker plant, my historical database, and my real-time processor on default ports in this case, making all the connections together, but those ports can be updated by a user. So off to the side here, I'm going to start my data feed, and interacting with the real-time database, I can basically introspect it directly using, in this case, basic.ordb, and then I can get a count of the feed. So I get access to the amount of data that's being processed as it goes. Okay, so that main ingestion path, and it's worth noting on this that main ingestion path is just queue processes. So the performance that it would have in a KDB setting is the exact same as it would be in PyKX in this instance. Slowing down of processing as we add analytics to these things is only going to be as fast as the analytics that you drive or the analytics that you run. And the result of that basically is that if I'm adding slow Python analytics, I may want to remove or limit the chance that slow subscribers kind of pollute that. So what I'm going to do now is I'm going to add a chain ticker plant. A chain ticker plant basically is kind of a replica of the main ticker plant, which is containing the logs, but it's basically just something that things can subscribe to that limits the chance that I'm going to be in a position where my entire system fails over. So starting the ticker plant here, kx.tick.tick on port 5013, say it's chained equals true. That basically means it doesn't contain any logs that are being maintained. And my start command is I want my chain ticker plant to get its information from a ticker plant on localhost 5010. So starting those up, we create the connections. Now for something a little bit more complex or interesting. So in the infrastructure above, we're basically at this position. So I have a feed handler, which is publishing my data. I have a ticker plant, which is maintaining those and getting the logs. I have a real-time database, which is kind of aggregating or taking in all of today's real-time data. End of day, it'll write it to my historical database. And I've created a chain ticker plant. In this blocks up here, I have a real-time engine. I have a real-time processor, which is producing a Python or will have a Python analytic on it to calculate the minutely bar data that I had before, the open, high, low, close for the minutely information. So to do that, I basically can define a post-processor function. This post-processor function will operate on the entirety of the real-time data that I have consumed and calculate the low, high, open, close, and volume data for the information I have. It'll do that X barred by 1, so it'll run that for all minutely bars within the data and also do it by symbol, making available for query the table minutely. What I'm also going to do at the same time is add 2 query APIs. So these APIs are basically for outside users to be able to get the full open, high, low, close information or just get the volume of trades that have happened by symbol. So I have one for returning the full data and one for returning just the volume, the sum of the volume for the symbols. So if I run those, I can now start my real-time processor. So this is more complex because it's running more complex things, and these things are all fully documented and will be available for the release. But to go through what arguments I'm providing, my real-time processor will be on port 5014. It will subscribe to data from the feed table that the ticker plant is presenting. It has a post-processor function, which I described above, for calculating the minutely information. That function requires the library PyKX to be named KX. And I have 2 query APIs, a volume API and an open high-low close API, which respectively are named Query API and OHLC API. Finally, vanilla equals false basically just means that it's going to require Python in order to start this up, and that there's going to be some hooks that I have access to. These hooks basically give me access to generate the APIs. Okay, so that's all started and data is flowing. To prove that data is flowing, I can test one of the APIs. So what I'm going to do is open a connection, synchronous queue connection against the real-time engine on port 5014 and run the open high-low close API for Gold USD. So if I run that, you'll see that I have access to the minutely information, and the final of those is increasing. So as the data is flowing through, we can see the volume of trades by minute that have existed for the Gold USD. Okay, at the beginning of this, I discussed that I was going to be producing a query gateway, and that gateway would allow me to query both the historical and real-time data. When I started the basic infrastructure, I produced a historical database, but that historical database didn't have any APIs. So in order to allow me to query that, I'm going to produce an API which basically does the query to get the total volume of trades for a given symbol. So this API here is basically that call. So in this instance, I'm going to be retrieving the the volume of trades for a month, because my database is partitioned on a month. So first of all, get me the dates that exist within my database, and then I'll have a number 1 to the number of dates that I can go back in time to get additional information. And I want to run a select statement on that data to get me the volume, or sorry, the sum of the volumes by where the date is in the specified range of dates and where my symbol is a defined symbol. So if I start that, retroactively adding in the libraries and the APIs to an instance of one of the streaming nodes is basically as follows. So here, basic.hdb.libraries, PyKX as KX, PyKX gets KX, and register API to register the HTTP query from above. Finally, I'm going to add my gateway. And for my gateway, I'm going to add 2 things. I'm going to add a validation function, which takes a username and password and validates that somebody that's connecting is allowed to do so. So in this instance, it's very simple. It's a username equals test user, and the password has to be password 123 or password numeric input. If the patterns match, return true. If not, return false. And then for my gateway, I'm going to be querying the various processes by name. And we'll see below that naming the processes that we're querying against is basically the name I want to give it and the host and port that it exists on. So in this instance, gateway.callPort, real-time processor, call the API, query API for the provided symbols, get a default amount of historical data. So if I'm not asking for greater than 0 months, I don't have any historical data. So I'm going to be adding basically the 2 tables together. But if months is greater than 0, I want to call the historical database with the same API with the symbol that I'm interested in and the number of months of data I want to get information for. So if I run this, I can then start my gateway. So very similar to the previous versions, I'm going to be running on port 5015. My connections in this instance I've discussed before is a map of the name that I'm associating with it and the host and port. Unlike the previous examples, I don't have PyKX. PyKX is not a required library in any of these queries, but the regex library is from Python. So in this instance, I want access to the ORE library as ORE. I want to define my API for query, and I want to define the validation function, the function that's going to be used to allow access or not. So if I run this, I'll initialize my gateway, port 5015, should register the APIs and register the functionality, and then I can test it. So the gateway was on port 5015. I had some specifications for what a user required. So if I don't meet those criteria, I'll get an access error, which says that I don't have access to connect. But if I run with the specified amount, we'll see that for today's data, because I've set 0 as the month, we can see that there is increasing numbers of trades for gold USD. But if I now increase it to 1, I'm no longer querying against a single process. I'm querying against multiple processes, bringing the results to a gateway and having the gateway return the results to me. So at that point, we now have 10 million records of gold USD, or 10 million trades. Okay, and then shutting everything down is basically stop commands. So all of these objects, or all of these processes need to be stopped in order to stop processing. And in each case, it's basically that syntax. Okay, so that provides a kind of an overview of the streaming work. That is obviously relatively non-trivial. The workflow that I produced there in about 10 minutes is reasonably complex. It contains a lot of APIs, contains a lot of queries, all Pythonic. But the intention is that this is entirely expandable by a user. We're not dictating what the infrastructure looks like. That's up to a user. While I'm running everything locally in my instance, there's nothing to say that the historical database couldn't be on a virtual machine in the cloud and my real-time database be on the edge, for example. The APIs and the functionality that's there is fully flexible, so that if you can create the connections between the processes, you can create the infrastructure that you want using this. Okay, so coming back a little bit to some of the API updates. In this instance here, generators for date information, more Pythonically. Mainly this is useful for doing the comparisons between some of the information within the query API, for doing a comparison against today. For example, if the date is before today, we would use datetime or dateAtom today. Similarly, for the timestamps, we've provided a constructor that allows users to build them up from scratch, but additionally get access to today's information, or now specifically. As I mentioned in the kind of introduction, help for native functions is something that doesn't exist today. It's generic return. So if a user is using kx.q.movingAverage or wants to use it within the query API, we now have help for that. So it gives you access to the underlying Q function that's used for it, but additionally an example of using the function in practice. One thing that had come up a number of times for more advanced users on the Q side of things was the ability to build workflows that made use of the Q inbuilt operators. So Q provides the ability for users to run functions or use its syntax to do lots of different behaviors. But because of how Python allows you to build APIs, some of it wasn't accessible directly. So in this case here, if I wanted to use drop, for example, I would have to define what drop was kx.q for an underscore, and then to use it, I can make a call to that, which is fine, but the overhead of doing it is reasonably large. Additionally, it's not possible for us to provide help to users and give them examples of how to use it. So the updated syntax or updated usage is basically that we've provided the ability for users to use kx.q.drop, kx.q.fill, enumerate, any of the kind of base operators in Q now have associated help and examples with them. So here, for example, drop items from a list, entries from a dictionary, rows from a table, drop the first 3 items from a list, and an example of doing that. In this instance, making a drop the first element, which is the equivalent of that. For something a little bit more advanced, fill allows you to fill null values with specified amounts or specified values. So in this instance, create a list, 1, a null kx object, and then 2, and fill it with ones, the return is now 1, 1, 2. And finally, functionally is for the Q users. One of the things that we've wanted to do with PyKX is to make the process of learning Q easier. And if you are a user that is principally a Q user, make it easier for you to develop in different locations that you may not have access to a Jupyter kernel with Q. So the way that we have updated PyKX in 3.0 is that we allow users to enable Q first mode for their notebooks. So essentially what we're doing in this instance is kind of hijacking Python's kernel or redirecting its kernel and allowing us to run Q as the first language. So the syntax that's defined here doesn't make sense in Python, but it is the definition of a standard scalar in Q. So running that, I can see it executed. And if I run the function with some data, I get a standard scalar response for that random data. Additionally, I can assign values to it. So if I have test gets 100 choose 0 ng, which is get me 100 random GUIDs in Q, that assignment now exists. But why is that useful? The reason that it's useful for users that are maybe building custom APIs for the query API work is that it gives you the flexibility and the ability to build APIs or build functions that you can then test. So if I have a big Q function I need to write that does an aggregation between two columns or runs some sort of analytic, I can run it Q first and then get access to the variable that I've defined. So here, kx.q index to get test gets me back the Q object that I had produced. So that is, from a flexibility and API development standpoint, super useful. But the important part of kind of the entirety of this release is that ultimately what we're trying to do and what we're intending kind of holistically to do is to make the experience for Python users as seamless as possible. So the expectation is that for 90% of the work that you would want to do from a data science perspective with Q data or KDB plus data, you should be able to do that now with the PyKX API. For that extra 10%, we want to make the process of learning Q more seamless. So the work that Ryan and his team are doing on evangelism for teaching that should help to move some of the way there. But obviously, a lot of the users in the chat here are users that are using PyKX are working in organizations that have access to Q developers who can then provide them training or can help them along the way. Okay, so now the scary part is over. I can finish off on a nice note. So when is it going to be out? The tentative release date is November 12th, 2024, which is a Tuesday. It's a good day to do a release. With the intention that all of the functionality that I've provided today will be released on that date, plus a number of other features that are kind of in the works right now. So there's a load of ways to get involved, and Ryan has kindly put the Academy stuff in there. Obviously, these QR codes exist. If you scan them, you'll get access to our GitHub, to our documentation, and to the Academy courses for PyKX as well. But with that, I just want to say thank you, and obviously, if there's any questions, I'm happy to answer them.
Yeah, so no questions yet, but all who are watching, please feel free, if you have any questions, throw them in the chat. One question that I had was, how did the PyKX team decide which features to add for the 3.0 release?
Sure. So the process of choosing the features that we work on is kind of it's a bit of a dark art to some extent. A lot of the features that you saw today, particularly the Q first workflows and the query API work, is done in consultation with clients. So some of our clients will request that they want to expand the user base for PyKX to only Python developers, and that in the instance where we're talking about the query API, they'll have seen potentially Citadel's presentation at KXCon, which had a rudimentary version of this. So we've produced a version that we're happy to support that allows more users to get value of the library. The streaming work however, is kind of a different thing. KDB Plus and Q have been used for 20 plus years now in streaming applications and streaming workloads. And PyKX didn't have access to that use case. So using kind of expertise within the team and an understanding of potentially the use cases that could be solved by the library, we've made a decision to produce an API that allows that to be as seamless as possible. So really it's mainly down to what clients request and what users request. But there are elements of our releases which really come down to expertise and kind of domain knowledge from our side, particularly around our functionality.
Awesome. Thank you. Thank you. Oh, we do have one question that came in. Can we build the ticker plant with unlicensed PyKX, or does it require the licensed version?
No. So the ticker plant work principally requires the licensed version of PyKX. As it stands right now, an awful lot of the orchestration and particularly the API elements of it are it necessitate access to the licensed version. We are ultimately spinning up Q sub processes. Users could build that themselves, but from the perspective of the supported elements of this, it's only supported in the licensed version of the library.
Okay. Yeah, and also, if you're trying to experiment with this again, over at the KX Academy, you can try this out with the sandbox environment, go through these courses. PyKX, Introduction to PyKX course is a good one to get started with, and then you have access to the sandbox and everything's installed and set up for you, so you don't have to worry about any license with that for your experimentation. And I think that is all the questions we have. Oh, here we go, one more. Can PyKX work with KX 2.7?
PyKX will be able to query KDB 2.7, I believe. It wouldn't be able to run its license mode version on it. And PyKX in the mode that I was kind of using today uses 4.0 or 4.1. They're the only versions that the kind of underlying queue is working on. But PyKX should be able to query against queue infrastructures that are running on KDB plus 2.7.
All right. All right. Well, that looks like all the questions. Big thank you, Connor. Thank you for that awesome presentation and the demo.
Thanks very much.
Really insightful, really interesting features coming out here soon. So a big thanks to you, and thank you to everybody who joined. Really appreciate your time coming to learn a little bit more about what's next with PyKX. Just a note about some upcoming events. On October 30th, we're going to have another live stream. It's going to be focused on temporal similarity search. So looking for time series patterns in your temporal data. For example, a little preview, this one will be focused on looking at some Tesla data and doing a bit of anomaly detection and prediction on that. So stay on the lookout for that. And then a little bit further in early November, we're going to have another live stream that's going to be focused on the combination of unstructured and KDB AI for those who are interested in the generative AI side of things. So with that, we'll close out the presentation. Thanks everybody for joining, and we'll see you next time.
Thanks, everyone.